Okay, number 5 says the cosine over this, 1 minus tangent, sine over 1 minus cotangent. So when I look at that, I definitely think start with the left side. So what do you do when you want to try to add these together? One thing we could do is we could get a common denominator, and that would work. So if some of you did that first, that would totally work. You just have to multiply this by 1 minus cotangent over itself, this by 1 minus tangent over itself. I thought instead of doing that, because we have these sines and cosines, I would put everything in terms of sine and cosine first. So the first thing I did was I changed this tangent. It's going to look a little messy at first, to sine over cosine, plus, then I replaced the cotangent with cosine over sine. And again, if you would have got a common denominator first, that's fine. I just thought that it might be better if we tried to get everything in terms of sine and cosine. All right, so then I saw that I had complex fractions. So in this fraction, so there are two separate fractions. In this first fraction, there's a cosine. So I need to get rid of that. So I multiplied by cosine theta over cosine theta. Everything in this fraction. So in the numerator, cosine times cosine is cosine squared. In the denominator, I have to multiply cosine times 1. And then with this fraction, the cosine will drop out. I'm left with minus sine. So that's what I'm left with. It looks a little nicer than the first one. Do the same thing with the second one, but now my denominator is sine. So this fraction, I'm going to multiply by sine over sine. So I'm going to get sine squared. Down here, I have to distribute. I'm going to get the sine for the first term. The second term, the sines cancel out, minus cosine. All right, so now I see that I'm close to having the same denominator. They're just opposites of each other. So to make them to be the same, what I'm going to do is I'm going to factor a -1 out of here, and I'm going to bring it up to the numerator. So what does that mean? That means if I take a -1 out of here, I'll be left with -1 times positive cosine and a negative sine. But instead of leaving that -1 down here, I'm going to bring it up on top with the sine squared. So I really have cosine squared theta minus sine squared theta all over cosine minus sine. Okay, so again, I just took a negative out of here, and that's okay. I can factor it out as long as I bring it up somewhere else in front of that fraction. So now I look at this and say, this is the difference of squares. Remember, I want to be left with sine plus cosine. This could be factored as the difference of squares. It can be factored into cosine minus sine times cosine plus sine. If you aren't sure of that, make sure you think about if you multiply this out, those middle terms that drop out, you'd be left with cosine squared minus sine squared. So we just factored it. And then once I factor it, now I see that, oh, yep, this cosine minus sines cancel out, and I'm left with cosine plus sine. Okay, so again, there's definitely other ways to do it, but if you're in doubt and not sure what to do, I think this would have got a little messy if you would have tried to get a common denominator right away. So if you put everything in terms of sine and cosine, then you can see that you almost have the same. If they're opposite of each other, you just have to distribute out a negative. All right. Second one, again, I see these fractions. I definitely can't, they're in terms of sine, so I can't simplify them any further. So I guess what I would do at this point, on this one, right away, I would get a common denominator. So I would have to multiply by 1 plus sine over 1 plus sine to get 1 plus sine theta over, I'm going to distribute, well, I don't think I'll distribute that. I think I'll leave it because I don't really want either of these things in the bottom. So we'll talk about whether we want to distribute or not. Or initially, I would say, I don't think I would. Maybe in the end, we will have to distribute that out. And the second fraction, if you multiply by 1 minus sine over itself, you will get 1 minus sine over, again, I won't distribute that right now. We'll talk about whether we should or not later. all right? And the only reason I'm thinking not possibly is because I want to make sure that they go away. So I'm thinking maybe something will cancel out, but let's see what happens. So when I add these together, I get 1 plus 1 is 2, and then sine and negative sign go away. So I'm just left with 2. So now I'm thinking, okay, I've got the 2 in the numerator. I want to get like cosine squared in the denominator. So now I'm thinking maybe I should FOIL these out. If I multiply 1 plus sine times 1 minus sine, I'm going to get 1 minus sine squared. And now I'm thinking, okay, now that I know that's 1 minus sine squared, what is that? That is 1, that's 2, over cosine squared. Sine squared, 1 minus sine squared is cosine squared. And I know that 1 over cosine squared is secant squared, so now I can just say that's 2 times secant squared. Because remember, 1 over cosine, so if you kind of think of 1 over cosine, that's the secant squared. Okay? All right, number 7. 7, I look at that and think, whoa, I've never seen sine. Oops, I missed a theta there. I've never seen a sine cubed. We have no properties for cubes. So when I look at that one, I think, oh, she threw in the sum of cubes. That's what I'd be thinking. So I look at that and say, we need to factor that as a sum of cubes. Those are both perfect cubes with a plus sign. So formula for sum of cubes is sine of theta plus cosine theta. That's a plus b. And then we're going to take the first term squared, so sine squared theta, minus the product of your a and b, so sine theta cosine theta, plus your b term squared. So there is the sum of cubes all over sine theta plus cosine theta. And then right away I see those cancel out, which is good. Then I look to see what I'm trying to get to. I'm trying to get to 1 minus sine theta. So I've got my minus sine theta. I need to get a 1, and if I look at this, sine squared plus cosine squared is 1. So I'm left with 1 minus sine theta cosine theta. So it ended up being a pretty easy proof if you knew this sum of cubes. All right, and then the last one. Last one, I look at that one, and I'm not real sure which side to start with. When I look at it, I just think this one's already in terms of sine and cosine, so I'm not sure exactly what I could do. I could factor this as the difference of squares, but I don't think I could simplify it any further. So I'm going to look at this side, because I can put tangent in terms of sine and cosine. So I'm going to put this in terms of sine and cosine, see what I get. Let's see, tangent is sine over cosine. And when you do this stuff, it seems like you're getting more complicated. But again, we just need to then get rid of our complex fraction. Okay, so that is, whoops, you can't see that. That is what I get when I take sine over cosine, and then 1 minus sine squared over cosine squared. My least common denominator is cosine squared to get rid of all of those. So I need to multiply by cosine squared over itself. Just multiplying by 1. So in the first fraction, one of the cosines will cancel out. So I'm going to be left with sine theta times cosine theta. Only one of those cosines will cancel out, so I have to take sine times cosine. In the denominator, 1 times cosine squared. And then here the cosine squareds drop out. And that is what I was trying to get to. I'm done. So when I put it in terms of sine and cosine, it was just a matter of then getting rid of that complex fraction. If this is cosine squared, I had to multiply by cosine squared to get that. And then you have to make sure you know what sine over cosine times cosine squared. You have to understand that one of the cosines will drop out, and you just have to write it as sine times cosine. Okay? So that's worksheet 1. Hopefully the video helped, and if you haven't started worksheet 2, be looking at trying to see if you can do worksheet 2 without my help.